Okay, good morning, one and all. So today the target is we are going to finish the experiment number 5 and 6 both today. So theory is done. Whatever simulation had to be done for fifth and sixth experiment, we will see today. And by today evening, I will upload the questions for fifth and sixth experiment. So we cannot go for seventh experiment immediately because seventh experiment is root locus. So root locus we have not done so far. We are still in the third module, so root locus will come in fourth module. So we have time because theory has not gone advanced. That's why we cannot go for experiment number 7 or ahead. So we have time. Every year the same problem happens, that is we give some 2-3 weeks time for this experiment 3 4 5 6 and all. Okay, so again, I will give you a very brief explanation of what all we have done today. So write down, first we will do experiment number 6, that is the steady state error analysis, and today we will see by MATLAB how the error looks. So that did not go well last week. We all were in a kind of a different phase of mind at that time. That is IA was there and a lot other things were happening, but today all the things are well set, so I think I'll be able to show you all the outputs very properly. So what we have done yesterday, I will just give you a brief recap in 2-3 minutes. That is, we had taken a system like this as it was shown to you, and there will be same system we'll be doing, and for that we'll be finding all the errors, steady state errors. So first we are doing experiment number 6, and after that we will do the second order response of experiment number 5. And second order response, there are 4 response: undamped, underdamped, overdamped, and critical damped. So we have seen very perfectly all the time characteristics and all for undamped, for overdamped, and for critical damped. Underdamped response, we got the response, but it was not matching with the calculated value that we had. So today I will show you, so where all mistakes I was making, that also I will show you. I was in hurry, so I was making a mistake. Whatever we calculated, it was correct. The process also we had done, it was correct. But where I was making the mistake, that I will show you. And the perfect waveform, so second order system step response, perfect kind of waveform, it will exactly match with what all calculated values we have done. So we had calculated for rise time, delay time, peak overshoot, and all those things. So perfectly it will match today with our output waveform. So that fifth experiment execution for only underdamped part we will see today. So if we finish it, I think IA1 is over. So paper I will check in a day or two and give it to you, all the marks. So by next Tuesday, you have to submit, or before next Tuesday, you have to submit experiment number 5 and 6. So write up is not much, only you have to submit the results and you have to write the conclusion. So first I will tell you what to do in experiment number 6, that is steady state error analysis. So whatever functions I have got here last day, if you remember, that is yesterday only, the same thing has been discussed and same things are uploaded actually in lecture number 27 and 28. I have uploaded by yesterday night or today early morning. So those 2 lectures, it's a request to all of you, please check both the lectures thoroughly. Okay, so experiment number lecture number 27 and 28, all the notes that are given, all the lecture, that is, so you have to give 2 hours. So I told you you have to do 4 hours extra, so it is not that. I think lecture up to lecture 24th was uploaded. 27th also you had done, that was I discussed about what is type, what is order, and in lecture 27 only you will find that discussion. There you will find introduction to a steady state error. And lecture 28, which was conducted yesterday, again whatever ending part of 27th lecture and starting part of 28th lecture, it was same. So 27 and 28th lecture, very important lecture. Today only, it's a request to all of you, please listen to both the videos. Okay, you can drag, you can listen it fast, because I have tried to explain too much and I have wasted some time, but it's okay, because very small trick, very small things I have explained in steady state error. So experiment 6th is actually related to those 2 lectures, that is lecture 27 and 28. So today this session will be over, and the experimentation related to steady state error also will be over. So what all things have to be taken? So you please sit with a pen and paper. It will be easier for you to understand. So I will also take one page because I'll be writing what all things I will be giving to you. Okay. And I will be showing you something, but you have to define your type 0, type 1, type 2 system and find what are the different responses. So write down, so I'm giving you time, so if you have a pen and paper, please write down what we are supposed to do in experiment 6. Okay, so experiment 6, job 1, so just write down like this, those who are having pen and paper. Experiment number 6, job 1, that is define type 0, type 1 and type 2 OLTF, like this. So this is the first job, define type 0, type 1 and type 2 OLTF. So in this numerical, what we have done, we have defined type 0, GSHS. So I have already started experiment number 6 explanation. Okay, so in this experiment we have taken type 0 GSHS as 2 divided by s plus 1. Okay, so the same thing you can define. Don't take 2 divided by s plus 1, and numerator better you don't take 2. Numerator G you define properly, but H you take as 1 only. Why, that I will show you when I explain tomorrow what is the third method of finding ESS. So I have shown you so far 2 methods of finding ESS. Third method I have not shown, so there is some practical difficulty. So you take your system, so you can take system as 1 by s plus 5, you can take 1 by s plus 7, so let it be different for others. Okay, somebody wants to take suppose 1 by s plus 3 into s plus 5, that also you can take. Okay, at the denominator instead of 1 you take 2 poles. Okay, so 1 by s plus 1 into s plus 3, that you can take as GS, and HS always take as 1. So that is my suggestion, HS always take as 1. So these are the different kind of type 0 GSHS you can take. So I have taken here, so I'm explaining this process if you anybody had missed yesterday's lecture. So what I've taken GSHS as 2 divided by s plus 1. Then first thing, so that was the first job. If you taking GS as 2 divided by s plus 1, that is type 0, what will be type 1 system? In that case, type 1 will be GSHS is equal to 2 divided by s into s plus 1. So just you have to multiply a s at the denominator. That will make this GSHS as type 1. How can you make it type 2? This denominator you have to make as s square. That's all. So the same system, whatever you define, suppose if you're defining 1 by s plus 5 as GSHS, then that will be type 0. What will be type 1? 1 divided by s into s plus 5. That will be type 1. What will be type 2? 1 divided by s square into s plus 5. So ये तुम्हारा 3 system हो गया. So first thing is define type 0, type 1, type 2. So type 0 is 2 divided by s plus 1 as per our present what this handwritten things also I have uploaded, so you can check that. So type 1 is GSHS 2 divided by s into s plus 1, and type 2 is GSHS is equal to 2 divided by s square into s plus 1. So this is what I have defined. This is the first job, define type 0, type 1, type 2 system. Then number 2, okay, job is define step input. Define step input. So that is equal to UT. Okay, so UT means A is equal to 1. I told you that it can be 2 UT. So if you are saying 2 of unit step, in that case here ES will be 2 divided by S. Okay. If I'm saying 1s, if I'm saying 1 unit step, in that case it will be 1 by s. If I say 5 unit step, in that case it will be 5 by s. But what is this? This part is actually 1 upon 1 plus GSHS. So you can find here ES is equal to RS. Okay. So RS, the way we will do it, we will find the error for 1 unit step and 5 unit step. So that is another thing. So define step input 1 unit step and 5 unit step, and we will find what is the system response. So this will be our case. So this is ES is equal to 1 divided by 1 plus 2 divided by s plus 1 and all these things, and we'll finding. And initially we are taking it as 1 by s. Likewise, initially we are taking as 1 by s. Okay, so what is GSHS? GSHS is equal to 2 divided by s plus 1. This is something we have to remember, or you have to assume that we are taking GSHS is equal to 2 by s plus 1, or h is equal to 1. Okay, so let us go to, this is our initial case. Let us go to our result. So what is the result here? Result is the error is 1 by 3, so that we have actually plotted. So how much is the steady state error? How much is the steady state error? So steady state error, we have found out for this system, steady state error was 1 by 3. Uh, just give me 1 minute. Okay, so steady state error is equal to 1 by 3. So this is the third page. We have found out how to find the steady state error and all other things. So this we had found, and then we had gone for other things. That is unit ramp response. So unit ramp response, the same system. So this is 1 plus GSHS, 1 plus 2 divided by s plus 1, and input we have changed as 1 by s square. Unit parabolic response. So here we will do two responses today. That is, one we will do for unit ramp, another we will do for suppose 5 ramp. So in that case, this input will be 5 divided by s square. Okay, and another case we will do here parabolic input. That is, we will be inputting 2 by t square by 2. So here a is equal to actually a is equal to 1, so it is half of t square. The next time we will give a as 5. Okay, so in that case we will find 5 by 2 of t square of ut. So these are the three inputs that we are going to enter to the system, and we'll be finding what is the system response. Okay, but here one difference is there. This is the first method, so here we are actually finding what is et. So et is equal to 1 by 3. We have found out that is for step input, unit step input. So first we will prove only for unit step input. For unit ramp input, we are finding error is infinite, and for unit parabolic input also error is infinite. So these are the three things we have found out. Now how to do the simulation? Okay, so how to do the simulation, that is the very important part. We got stuck here, and let us find out how to find the simulation. Okay, so for the same system, there is a caution. For the same system there is a caution. So start, those who are having pen and paper, you can write down that first case GSHS is given as 2 divided by s plus 1. So I'm defining a numerical. Actually I'm defining a numerical. Those who are having pen and paper, you can write down. So this was the initial explanation of the thing, so we are not going to see this thing anymore. We will go to the MATLAB, and I'm going to find in the MATLAB exactly how and what I'm finding. So I'll launch my MATLAB, and we'll define a numerical and we'll find it. So I'll go into MATLAB now. Any of you, can you please confirm if my MATLAB screen is visible?
Yes, sir.
Okay. So write down our first numerical that we are going to solve. So in your journal also you can do that. Okay. So first let us say that our system. Okay. So we will do this proof first. Our system is equal to 1 by s plus 5. That is equal to gs and hs equal to 1. Okay. So how to do it, I'm showing you. First let us say our system gs is equal to 1 by s plus 5. So ये आप लोग लिखते रहो, just keep on writing. So gs is equal to 1 by s plus 5, hs equal to 1. Okay. So whenever we are trying to find out the error, now actually I am telling you the method 3. So method 1 and method 2, what we have done. Method 1 and 2 is for calculation. Method 3 is what? So method 3 we are going to do now. So method 3 says that we can find out, okay, we can find out the error from closed loop transfer function. So whatever open loop GSHS is given, from there we will find its closed loop response, and we will plot this closed loop response. And from the closed loop response, we will find out what is the difference between input and output, and that will be actually the steady state error. So this is the code I am doing. So if you are there, you can also do this code. The same code is given to you. What I am doing is inverse Laplace transform to find out a system transfer function. Here to find, I will just change here to find the steady state system error. So this is my code, inverse Laplace transform to find the steady state system error. So CL close here, CMCS and all this thing is there. YS is the closed loop transfer function of the system TS. Okay, now here what is TS? Okay, so I'm just doing here just to show you what is TS. Okay, so TS will be equal to GS. So this is actually I'm doing just to explain you, this is not a part of code. Okay, divided by 1 plus GS into HS. This is a very important thing I'm telling you. This I did not explain. This actually I'm finding the steady state error by third method. Okay, and third method was not explained to you. I had only explained first and second method. So we will find it by third method and we'll verify with first and second method. Okay, so TS is equal to GS divided by 1 plus GSHS. Now what is our GS here? Okay, so GS is 1 divided by S plus 5. Just now we have assumed 1 divided by S plus 5. So this is our GS. And what is HS? HS equal to 1. So this is ये हो गया GS, this is GS. First we have to find what is closed loop transfer function. So here we will write CLTF is equal to. Okay. So in the first method and second method we were finding GSHS. In the first method what we found was we found error is equal to RS divided by 1 plus GSHS. From there we found ES and we applied final value theorem, that is limit S tends to 0 S into ES, and we found what was the error. Second method, I'm trying to find out first error for unit step input. So find inverse Laplace to find steady state system error. So first I will take find error for step input. Okay, and find state for state input and for zero type or type 0 system. If you are having any doubt, please ask. So why is it type 0? Because in this case I'm taking a GS as, in this case I'm taking GS as GS equal to 1 by S plus 5, S plus 5. This is what I'm taking as GS. Okay, so there G is equal to 1 by S plus 5. So 1 by S plus 5. So 1 by S plus 5 means in GS there is no pole at origin. So 1 by S plus 5 means only one pole is there and HS equal to 1. So this is always I'm asking you to do. So all the numerical you take HS equal to 1. This is what you take. So what is GSHS? GSHS is equal to, so GS is equal to GSHS equal to 1 by S plus 5. So in that case you are finding open loop transfer function is not having any pole which is at origin. That means here actually what I can find is S tends to 0. Okay, that means it is a type 0 system. So this is very important thing, type 0 system. I found out. How can you make it type 1 system? Just make here, okay, just make here S multiplied by. So ये हो गया type 1 system. How can you make it type 2 system? Just make it S raised to 2. So ये हो गया type 2 system. Okay. So in this first case we are taking only type 0 system. HS is always equal to 1. So this is a type 0 system. But steady state error in the third method we cannot find from open loop transfer function. So for that we have to find out what is CLTF. Okay, so CLTF, how can we find out? This is GS divided by 1 plus GSHS, that is 1 divided by S plus 5. So how to find CLTF? You calculate and just tell me 1 divided by S plus 5 divided by 1 plus 1 divided by S plus 5. So this is 1 divided by S plus 5 plus 1, that is equal to 1 divided by S plus 6. So we can find GS by 1 plus GSHS. So this will be 1 divided by S plus 6. Okay. So up till this, if there is any doubt, please tell me. I took open loop transfer function forward path gain as 1 by S plus 5 and HS I took as 1. So CLTF, that is a closed loop transfer function. So I'm telling you the third method of finding the steady state error. So in third method, first I have to find CS. So I have to find output. From there I will find CT and I'll find out what is the value of CT, that is the output at t tends to infinity, and that is steady state. Then I will subtract output from the input, and that will give me the error. So first I have to find out what is CS. So while finding CS, TS is equal to, I can say here, this is CS by RS. Okay, so this write up about this third method also is there with me. I will post it today. Looking at that, you will understand. So CLTF is equal to TF. We have seen that for closed loop system, obviously with negative feedback. So CLTF is equal to TS, CS by RS, GS by 1 plus GSHS. GS is 1 by S plus 5. And now you are finding that CLTF is 1 by S plus 6. Is it understandable so far? Just anybody tell me. Is it understandable?
Yes, sir.
No problem, right? Okay. So 1 by S plus 5 you have to define. But when you are finding actually the closed loop transfer function, it will become 1 by S plus 6. That we are finding. Now what we have to do is, this is our system. Now we will be finding what is called as the step response. Okay. So now this is our YS. So this is now our YS. So this is 1 by, isko rakhte hai. Actually this is the code I did yesterday for our second order system thing. So I will keep this. So now what we know is our system is now YS, and YS is now 1 by S plus 6. So ये 1 by S plus 6 कहाँ से आया, that you have to understand first. 1 by S plus 6 comes from CLTF. So all the steps I will keep. Okay, all the steps I will keep like this. Okay, so again I will give you a recap from the beginning. What we are trying to find out, steady state system error for type 0 system. Type 0 system I'm defining first. For that GS I'm defining 1 by S plus 5. Same system will take type 1, we'll just multiply it with S. Accordingly the change will come in denominator. And for the type 2 system we'll take S square here. Okay. So understanding I will develop like this. While you are doing, you take more complex system, it will be easier. But the fundamentals will remain same. So HS I have taken as 1. Always you take HS as 1 for all your simulation. GS whatever you want you can take. Here you can take S square plus 2S plus 3 also, it doesn't matter. But here there is nothing. Okay, so here there is no S. So that's why this is type 0 system. Now YS is the CLTF of the function. Whatever TS we have to find out. So that is CS is equal by RS is like this. Now we want to find CS. So how do we find CS? It is here actually, everything is given here, step response. So here we are finding the step response of the system. Okay, so this is uncomment, and this code I will just take above. Okay, so only this much you have to do. So we are actually transferring the system into time domain. Comment. Only ये 3 line का code है. CLTF you have to calculate. So CLTF you have to calculate on paper, and then that you have to plug in this code. So this code is just for plugging in code. So there is a code, only 4 line ka code hai. CL, close all, clear all, sims of S like this, and then after that YS is equal to 1 by S plus 6. This is coming from the GS and HS, and A is equal to YS by S. What is YS by S? YS by S is nothing but the step response. Okay, because YS is this. So this is CS by RS. CS by RS is equal to YS. Now we know. Okay, and now CS is equal to RS into whatever this 1 by S plus 6. That means this whatever you CLTF you get, if you divide by S and find the inverse Laplace, then you are actually getting the step response. So this is actually your CT, step response, CT. That means output equation you are getting. I'll run it now. Okay, so if you are running it, you will find what is this. So this is 1 by 6 minus like this. So this I will not take. So what is the Y? So step response, step response. And what is the input? Input is unit step. That is very important. Input is unit step. So what is CT? CT is 1 by 6 minus e raised to minus 60 divided by 6. Now you copy it, okay, and you take it to the pole to time domain response thing. Here you take it. So now you paste. That's it. Okay. So response is equal to this. You have to take response is equal to this thing. Okay. Now you have to plot it. That's it. So this is percentage I will give. Response is equal to 1 by 6. Now what you can plot is up to 0.01. So this is another thing, up to 10, 5 karo, so up to 5 times response is equal to this, and plot t comma response. तो 6 लाइन का कोड है, 4 लाइन उधर 2 लाइन इधर, तो हो गया plot t comma response. What is meant by plot t comma response? Plot t comma response means whatever is time, with respect to time you are plotting this response. So 1 by 6 minus e raised to minus 60 divided by 6. So this actually we are plotting the output. This is not the error, okay, because I told you that first method, that is ES is equal to RS by 1 plus GSHS, directly gives us ET. That method we are not applying here. Second method, we will prove it shortly. By second method we can find what is the step error of this. So in that case we find what is called as KP. Okay, so what is KP? Can anybody find what is KP here and tell me? KP is limit s tends to 0 GSHS. Okay, can anybody find KP and tell me?
One by 4.
1 by 4 or 1 by 5?
1 by 5, sir.
1 by 5, that is 0.2, right?
1 by 5.
So KP is limit s tends to 0 GS into HS. Okay, so I will go back to this diagram, sorry, this case. So GS is 1 by s plus 5. So GS into HS is 1 by s plus 5. So limit s tends to 0, 1 by s plus 5. So there you have to substitute s is equal to 0. So you will find that KP is equal to 1 by 5. 1 by 5 is equal to 0.2. If KP is equal to 1 by 5, that is 0.2. How much is the steady state error? So steady state error is 1 divided by 1 plus Kp. That is 1 divided by 1 plus 0.2. That is 1 divided by 1.2. How much is 1 divided by 1.2? Very easily we can find out. 1 divided by 1.2. How much is that? Anybody, if you are calculating? 1 divided by 1.2 is equal to 0.833. So ये result हमको लाना है 0.833. Is it understandable? Okay. So we have found that by calculation, by method 2, for unit step input. Unit step input means A is equal to 1. Okay. So Kp is equal to 1 divided by 5. Okay. So 1 divided by 5, because this is equal to 0, so that is equal to 0.2. And ESST. So this is ESST. ESS means steady state error. So ESST for unit step input. तो आज थोड़ा पेन एंड पेपर में लिखते जाओ तुम लोग. 1 divided by 1 plus 0.2. Okay, so that is equal to 1 divided by 1.2. Okay, that is equal to 0.833. तो हम लोग को ये 0.833 देखना है. Graphically we have to see this is 0.833. ये हम तुमको दिखाएंगे. So this I could not do last day because there were small things that I missed actually, and I actually did not tell you about steady state error and other things. आज हम देखेंगे ये. Okay, so this is 0.833. This we will check. So what we have done is we have taken this response 1 by 6 minus e raised to 6. So all those things I have done. Now plot response. So plot response means save. And how much is the difference between input and output? So what is input? Input is 1. That you have to remember. Input is 1. 1 means steady state. Input means 1. 1 means unit step. I'm sorry, not steady state. Input is 1. Okay. अभी देखो दिख रहा है output. Are you able to visualize the output, students? Is the output visible?
Yes,
out of the blue graph? दिख रहा है ना?
Yes, sir.
Okay, so this is what is this? This is actually the step response of the system. Step response means this is CT. Okay, so what is the CT value? What is the CT value here? You can check. What is the CT value? दिखाएगा वो. So ये अभी steady state में गया. At this point, at some time, it will show how much is the time value. So at steady state 4.31. So at time 4.31 second. Okay, V output is equal to 0.1667. And what is input? Input to the system? Input to the system is 1 because this is the unit step response. So this is called as unit step response. Unit step response means input is equal to 1. So input to 1, CT for closed loop system. So what very important thing now I'm telling you, from GSHS. So GSHS is actually a open loop gain. So there we have not formed the closed loop. GSHS is an open loop thing. So whatever we have seen here, if you see in the right side, whatever things we have assumed here at the top, I'm sorry, in this inverse Laplace thing, okay, whatever thing we have assumed at the top here, right, that is GS, HS and other things. So this GS, this HS, all these are open loop things. Okay, we have not found it to be closed loop. And how did we find this? How did we find this error TS? Sorry, not TS. How did we find this error? Just by substituting limit s tends to 0 GSHS. So from there we had found KP. So whenever we are finding KP, these values, whenever we are finding KP, that time also we have not made it closed loop. So everything we are finding from open loop. KP is found from open loop factor only. Open loop factor is GSHS. A is equal to 1. So A is equal to 1 means we are giving unit step. Unit step means input is 1. Okay, वो जो बहुत ऊपर है, इधर 0.2 तक दिख रहा है, input बहुत ऊपर है, input. So it's a flat line. Input is 1. But how much is the output we are finding? Output we are finding as we have seen 0.1667. So how much is the error now? How much is the error now? Error is unit step. Error is unit step, that is 1 minus this 0.1667. And how much is that? 1 minus. So how much is the difference between input and output? Are you getting difference between input and output as 1 minus 0.1667? How much is that? Are you getting 0.833 or something? So input is 1
Yes, sir.
and output is 0.1667. So difference between that is 0.8333. समझ में आ रहा है?
Yes, sir.
समझ में आ रहा है क्या बोल रहा हूँ? Okay, so input I am not plotting here because input is a parallel. Input is a parallel kind of a thing. This is nothing but unit step. Okay, and this is the unit step response. I will just try. I will just try if I can plot unit step also. Okay, so here in the plot, I'm sorry. Here in the plot, so whenever you are showing in the graph, you have to show like this. So here what you have to plot is t comma 1. Let me just try whether I can plot it. Okay, so this is step like this. Give some time for the output to come. Okay, so you can see this top line. This top line is nothing but UT. Okay, it has not come, but this top line is UT. Okay, and initially at this point, how much is the error? So input is 1 and output is 0. So initially the error is 1 minus 0, that is 1. And as time is going by, the output is increasing. As time going by, the output is increasing, and output has come here now, the value of 0.16664. So this is actually the steady state value for this function. So whatever is the distance between these 2 points, okay, whatever is the distance. So this says input is 1 and output is this. Okay, so this distance is nothing but the steady state error. For that steady state error, you cannot find here. At this point, the output is increasing. At this point, the output is increasing. You cannot find steady state error here. So first, let the response get steady. Let the response get steady. That is the first thing. Steady means it has reached a level and it is not crossing that level. So this is the first thing you have to see. And in this case, whatever is the difference between input and output. So input is 1 and output is 0. Okay, so output is 0.1667. So this distance actually is the error. Okay, this is what we are finding out. Next, what we will do is, next we will find the same thing, but for error for 5 into unit, or let's say 3 into unit step. Okay, so same thing I will do here. A is equal to 3. Okay, so what I'm doing is for unit step nahi, so we'll call it 3 into unit step. So a kya hai? A values and all those things you are not able to understand. So that a thing I will show you. So if I'm inputting the value as input a as 3. So if I'm inputting the value of a as 3, at that time what happens? I will just show you. Okay. So do the same thing. Go by the same method. So in this case, 3 into unit step a is equal to 3 kp. What will be kp? Kp will be 1 divided by 5. So kp value also will not change. Kp is 1 divided by 5. Now ESST for unit step, it will change. Okay, it will be in this case it will be 3. Okay, because here the a value will come. So now I'm doing the same thing, but I'm finding the steady state error for, so for the same system. So for the same system, find error, find ESST for, so find ESST for 3 into unit step input. For 3 into unit step input. So where will the change come? Change will come here. Okay, so this will be 3 divided by 1 plus 0.2. What is 0.2? 0.2 is nothing but kp. So it is a divided by 1 plus kp. So now it will be 3. Okay, divided by 1.2. So how much will be the error? 3 divided by 1.2. Now this will be 2.5. So now I'll show this 2.5 difference like this. Okay, now I'll show you this 3 divided by. So where will the change come? Change come here. So y is equal to 1 by s plus 6. Now this s will be actually 3 by s. Okay, because whenever you are doing a Laplace transform, in that case unit step is giving you 1 by s, but 3 of unit step it is giving you 3 by s. So whatever ys is there, that you have to multiply with 3. So now it will become 3 divided by 3 into ys by s. So this will be the change. Now you have to take again another inverse Laplace. So the coefficients and everything will change here. It will be now like this. And how much will be the error? Error will be 2.5. So this 2.5 I have to show you. Okay, so now this thing will change as I have changed the value of input from so now this will be t of 3. Okay, like this. So where are the changes that you have to understand first? So first changes is everything else remains same. GSHS, all those things, KP remains same. Only this part changes. Okay, for 3 into unit step input, because I am now giving 3 unit. A is equal to 3, KP is equal to 1 by 5, doesn't change. Here also changes comes. Okay, because here and here change comes, because now this is 3 by s. Okay, now response is I Laplace of A. Now you can change. Previously it was 1 by 6. Now it has become 1 by 2, and it was e raised to minus 60 by 6. Now it has become by 2. Okay, so this e raised to minus 6, no changes comes here, but only the amplitudes part it changes. So now I'm plotting it for t is equal to 3 and t of response. Okay, so the response has changed now. Now see for 3 of unit step, how does the output come? How does the output look like? And we will find that error is 2.5. Okay, so that we have to prove. So just check how much is the
Excuse me, sir.
amplitude. Yep.
Sir, someone is trying to admit. Please admit. Yes, sir.
Okay, so now how much is the output? Now output is actually 0.5. Okay, so as I have taken input as 3 times, so output also has become 3 times. So it is nothing but a very linear relationship. So now the input is 3 of ut, so 3 of ut is nothing but here 3, and output is 0.5. So now the output has reached to steady state. So difference between this 3 and 0.5. So this is actually the error now. So this is actually the error is now 2.5. This is what we are supposed to do. So for once for unit step you find, and another for 3 of unit step or 5 of unit step, all these things you find. Okay, so now I will go a little faster. Now I will do the same thing for unit step. So how to change the amplitude, that I have shown you, that is not a big deal. And a also will be equal to 1, and this is going to be 1, and this is 0.33. So 0.833, what all things were there. Okay, तो अभी छोड़ो, अभी हम लोग क्या करते हैं? Now we will be finding for the same system, we will be finding what is the second thing, that is the unit ramp error. What is the unit ramp error? How can you find unit ramp error? So for that you have to find kV. Okay, so what is kV now? Okay, so just find out kv is equal to limit s tends to 0 s into gs into hs. So limit s tends to 0, s into gs is 1 by s plus 5 and hs is 1. So this is 0 divided by 0 plus 5. So kv is equal to 0. That means what is the ramp error input? So ramp input error will be is equal to 1 by kv, that is 1 by 0, that will be infinity. Okay. So the same thing you have to do, kv. Okay, so kv, how do you find kv? Anybody who has tried it out, you will be finding that the kv value will become 0. How do we find kv? Kv is nothing but GSHS, that is whatever you are having here, GS into HS into S. Okay, and limit S tends to 0. So as there is a S coming in the numerator, if you substitute 0 there, so it will be 0 divided by 5. So kv will be equal to 0. If kv is equal to 0, at that time you will be finding that for unit ramp input, I'm showing you now. So ESST for unit ramp input will be 1 divided by 1. So this will be like this. As kv is equal to 0, it will be 1 by 0. So 1 by 0 is nothing but infinity, like this. Okay. So this is what we are supposed to do. So ys does not change, but only thing changes is unit ramp input is that 1 by 0, it will become infinity. So this infinity we have to prove now, and I have to show that error is infinity. Okay, that I have to show you now. ये समझ में आया? We are finding kv. How to find kv? Kv is limit s tends to 0 s gs hs. So there you substitute gs as 1 by s plus 5, hs as 1 s gs hs. So you'll be finding kv as 0. So this is the same type 0 system, but instead of unit step, I'm sorry, this should be unit ramp. In this case, we are giving unit ramp input by method 2. A is equal to 1, that is amplitude of the ramp. Ramp actually is t, so this is 1 into t. kv we are finding limit s tends to 0, s gs hs, kv is 0. ESST for unit ramp is 1 by 0 infinity. How to find this unit ramp? So that I will show you now. And step response to ho gaya, and then we are supposed to do by ramp response. So I think this ramp response part I will take up. Okay. So ramp response is nothing but whatever ys is there, you have to do ys by s square, that's all. Okay. So previously for step response we did ys by s. Now for ramp response we have to do ys by s square. That is a unit ramp response. If it is 3 ramp response, then this ys should be multiplied with 3. Okay, so that's it. So bs is equal to ys by s square, ramp response. So just check what is the inverse Laplace and take that into time domain and plot it. And you have to show that that error becomes infinity. So now response is equal to, so here we are going to v like this. So here we will plot input and output together. T response. So what is this t? First t, this is with respect to time, we are plotting t. Okay, this is 1 into t actually, because this is unit ramp. This is t and 1 into t. So instead of 1 into t, we are writing only t. And third t is time, fourth t is the response. So this first 2t, t with respect to t. I will just show you what you plot t with respect to t. In that case, we are going to get a ramp line of unit step. Unit ramp. And second t with respect to response, you will be finding what is the response of the above line. Now you can check here. This is the thing I had explained yesterday. That is, this is having 3 parts. Okay, so this t by 6 part is going to diverge with respect to time. So as time is increasing, this t by 6 part will keep on increasing. As time is increasing, this e raised to minus 60 by 36, this part will keep on reducing. And as time increases, this 1 by 36 part will remain constant. So this is a type 0 system, and this is a unit ramp input. Output will be having 3 parts. So one part will be diverging, and because of this part t by 6, the error will be infinite. Okay, so how to see the error? Now this is a very important thing. How to see the error? Now see the plot, and you will find how to show the error. So exactly this graph you have to show. So here input and output graph will come. So input is t with respect to t. So देखो ये blue graph जो है, this is actually t with respect to t. Okay, so at any time you will be finding x and y, they are same. at any time. So this blue graph is actually input. You can put legend here. The input is equal to output. What is the amplitude of the input at 3.58 seconds? That is equal to 3.58 seconds. And the same thing here below. Okay, how much is the output? So at 3.65 हो गया, थोड़ा आगे पीछे हो रहा है. Don't worry about that. Okay. So the output is not increasing at good as the input that you are finding. Okay, so output is not increasing as fast. Okay, so almost same. So 3.58 time and 3.61. They're also at one point you have to draw this line. Okay, so you know at 3.61. So what we are finding is at 3.61 seconds. So output ऐसे लिखना है at 3.161 second. Output is actually 0.573889. Okay, and at output at input at 3.61 second, input and 3.61 second is equal to 3.61. So you can find out, so those who are doing it, error at 3.61 seconds, that is equal to 3.61 minus 0.57388. That's it. Okay, so at any time you have to compare the input and output. So this blue graph is the input graph. At any time input is equal to output. So at x, output is t. So at 3.58 output is 3.58. Output is actually input. So this is the input line. At any point time and input will be same. So at 3.61 also this blue line will give 3.61. So here you are finding for the below. So this below red line is the output. Okay, and you are finding that input and output, they're diverging as time goes by. Now let us do one thing. Okay, so okay, let me first explain it. So draw a line at 3.61. At 3.61 you are finding output is 0.573889, and at 3.61 input will be 3.61. So how much is the error at 3.61? It is 3.61 minus 0.57388. So that is around 3.0361. So this is the error at 3.61 seconds. कोई बोलेगा सर मुझे error मारना है, you can do that. Okay. Let's say so MATLAB is giving some problem. Just once again it is launching. There might be some internet issue.
Sir, I have one doubt, sir.
Yes, please.
So how can you find a steady state error for RAM, sir? It is not steady at particular time.
There is no steady state error because the waveform is not getting steady. That's why it is calling us infinity. Very good question you have asked. See that input is increasing like this, output is increasing like this. So output is never getting steady. So there is no steady state error. Steady state error is infinity. That is what I was going to show you. Kiran, is it understood?
Yes, sir. Yes, sir.
It is not getting steady. That's why the steady state error is infinity. What is meant by steady state error? So I am assuming that infinite point is steady state, because infinity के आगे हम लोग जा नहीं सकते. And you are finding that these two graphs are actually diverging. Whenever the graphs are diverging, means they are not showing. So previous graph you found, the previous graph, what you found, this was the unit step, and this was parallel, the below line, that is for unit step response, and there was a constant gap between these two, and that gap was around 0.833 or something. Okay, so because this below waveform, it got steady. What is meant by steady? Steady means output is not increasing or decreasing, it is steady at a value. But for this graph, whatever we have shown, we are finding that output is increasing, input is also increasing. So there is no steady thing in the input and there is no steady thing in the output. So that is what I was going to plot, and we are finding that the difference between input and output is actually increasing and it is widening up. So as time is increasing, their difference is also increasing, and I wanted to plot it at 500 or 50. Let us plot it at 50. So for steady state error, first the output should get steady. But is your output getting steady? Kiran, can you answer this question?
No, sir. It is increasing with
Is the
time.
ramp response getting steady? Ramp response is not getting steady because it is type 0 system. For type 1 system, we will find that the difference between input and output is keeping constant. ये waveform जो दिख रहा है ये याद रखो. Is it understandable? This difference is widening. दिख रहा है? Is it
Yes, sir. Yes, sir.
understandable? Kiran and everybody, this distance is widening, and this distance at t is equal to infinity is called a steady state error. And as you are increasing this, so if I ask you that at 10,
Your screen is not visible, sir. Presentation.
okay, correct,
Yes, sir.
correct. Screen is not visible because I have to again launch it because. Just give me 1 minute. Let me know if the screen is visible.
Yes, sir.
Yes, sir.
Okay, so now see that I have plotted it now for 50. Okay, I can plot it for 500. So at 10, how much is the distance between input and output? Okay, have you all understood that steady state error means difference between input and output? Have you understood this much?
Yes, sir.
Have you understood this much? Okay, so steady state error means difference between input and output, and we are assuming that t is equal to infinity is steady point. That means there everything is steady. Is the graph visible now?
Yes, sir.
Okay, so here just check how much is the difference between input and output. Ye chota sa. Okay, around 0.8, 0.7, whatever it is. At 20, how much is the difference between input and output? बड़ा हो गया. 30, how much is the difference between input and output? बढ़ रहा है. समझ में आ रहा है? Is it understandable, you guys? That difference between input and output, the red line and blue line, where red line is the input and blue line is the output. This distance is increasing with respect to time. So how much is this distance going to be at t is equal to infinity? So can I say that this distance also will be infinity at t is equal to infinity? Understandable or not?
Yes,
Guys, please respond. Otherwise, I cannot proceed.
Yes, sir.
Yes, sir.
Understood,
Come
sir.
time में distance कम है between input and output. So if I ask you how much is, so whenever you are writing the error for this system, so if you are at 10, okay, or ये दिखा ना 9.67, how much is the output at 9.67? Below graph, check करो. Okay, so input is 9.67 and output, how much is the output? The output is 1.59. So how much is the error? 9.67 minus 1.59, so around 8. So error at 9.67 seconds. You cannot say that error at steady state because dono steady nahi ho raha hai. Okay, and this error is increasing this much at 9.67 seconds. The difference is 9.67 minus 1.67. Let's say error is 8. But at 30 the input will be 30. Okay, but at 30 how much is the output? Almost, just check karo. उतना बढ़ नहीं रहा है. Okay, output. So at 30 the output is 5. So how much is the distance? 31 minus 5. So error increased. Error has become now 26 unit. So at 9.67 seconds time, the error difference between input and output was around 8. This much was the error at time 9.67. But at 30, okay, the difference input will be 30 and 30 the output is 5.04. So this difference has increased. So likewise, if you go towards infinity, how much will be this distance? This distance also will go into infinity. That's why it is called as at steady state. Steady state means at t is equal to infinity. The waveform is not getting steady. Previous response, yaad hai? Step response. Guys, please respond. Do you remember the previous response?
Yes, sir.
This was input was at the top and this was the output response. फिर से और एक बार plot करता हूँ. Should we plot it again or if you remember that? मुश्किल है. Do you remember the step response? Just now I had shown you previous to this.
Yes, sir. Yes, sir.
Okay, so the step response was going up
Yes, sir.
and it was getting steady like this. चलो और एक बार plot करते हैं. यार तुम लोग बोल नहीं रहे हो तो how can I do that? फिर से पूरा प्रोसेस करना पड़ेगा. Okay, let us
We remember, sir.
comment. इतना क्यों तकलीफ हो रहा है मुझे पता नहीं.
Sir, it's okay. We remember, sir.
Because people are not responding. What can I
Sir,
do?
we responded, sir. You didn't hear it.
I don't even know whether they're there or not. So previously we had plotted the step response. Okay, and step response got steady. Kiran, please respond if you have understood. So is it understood? This is steady.
Yes, sir. Yes, sir.
Have you understood? This is steady.
Yes,
So
sir.
this is response for step. It is got steady at 0.1667. It is not changing. Okay. But whenever you are plotting for ramp, you will be finding that this response is not getting steady like this. In that case, the output is still increasing. Okay. And as output is increasing, input is also increasing. We are finding that the difference is also increasing between input and output. And as time is increasing, the distance is increasing. Okay. That means that t is equal to infinity. The difference between input and output that will become infinity. So that's why it is called as steady state error is infinity in case of unit ramp. For unit parabolic also you will be finding the same thing. So I'm just plotting it here. So I will do all these plots again and I will upload it in your group like this. And in this case you have to plot t comma t. So first t comma t is nothing but with respect to time you are plotting the ramp and then you are plotting the response. So blue one is the input and red one is the output that is plotted. Just check. And this difference you have to check. So see, simply do function analysis. This blue is a function, red is a function, and they are diverging. That's all. So instead of 5, if you are putting 5,000, what you are finding? So again, I'm plotting the same thing. So here you can check x-axis is 5. Now I'm plotting for 5,000. It'll take quite a lot of time. And you'll be finding that the difference is ever increasing. The gap is not getting mitigated. The gap is increasing. Dekho, kitna बढ़ गया distance. So how much is the output here? The output here is less than 1,000. So output is around 832. And at 5,000, how much is the input? 5,000. So at 5,000 second, how much is the difference? 5,000 minus 832. How much is that? Around 4,200. So this is actually the difference between the input and output, and it is increasing. So at steady state t is equal to infinity, this distance also will become infinity. That is what is called as steady state error, but output is not getting steady state. Output is also increasing, input is also increasing. It's a relative distance you are trying to find out. That is what is called as steady state. So it is infinity. Same thing for parabolic response. Also you will be finding that. So unit parabolic response, now it is comment. Unit parabolic response. Now here the parabolic response is there, y by s cube, like this. So I will copy this. I will copy this part and I will take it up like this. V. Sorry. Now you will see what is the parabolic response, how it looks like. So parabolic response or square wave response, anything you can call. And how it looks actually, ek baar dikha dete hain. This we are doing for type 0 system. Next we will be doing it for type 1 system. So this is uncomment. So y is equal to 1 by s plus 6. There is no change. Y is by 1 plus s cube. So if you start doing this whole exercise, it will not take more than half an hour to find out all these 9 outputs. So now see, this is the response we are getting for parabolic input. So now take it and plug it here. plug it here V. Okay, now this is t square by 2, t square by 2. So this is what you do. So these are the two graphs you have to plot. Okay, so the first plot is between input, so t and t square by 2. Okay, this is nothing but the input. So with respect to x, this is the blue graph. This we are going to generate. And then with respect to t, you are plotting what is called as a response. And response is nothing but it is a response like this. So ये आएगा नहीं शायद, I think इसमें एक there will be some problem. Let me see. Hold to time domain response. Let us see what it gives us. Okay, so here you will be finding the problem. So t raised to, so यहाँ पे dot आना चाहिए, because here there is a matrix multiplication kind of thing coming. So t and t dot square by 2. So ये याद रखो कहाँ पे dot आना है. Whenever you are finding t raised to, there you have to put a dot. So row column का गड़बड़ होता है वो देखना. So you have to just find out what is the difference between. ये देखो, the blue line is the input line. Okay, it is square, and the red line is the output line. So this is also a square wave, and their difference is ever increasing. ये हो गया. Understandable, guys?
Yes, sir.
So what is the difference between blue line and red line? This is ever increasing. ये थोड़ा hypothetically तुमको देखना है. ये डिस्टेंस अब कभी कभी क्या होता है, ये ब्लू और रेड दोनों इंक्रीजिंग होता है, बट दोनों के बीच में डिस्टेंस परफेक्टली सेम रहता है. अभी हम फर्स्ट ऑर्डर सिस्टम करेंगे तब देखेंगे, बट इन दिस केस इट इज नॉट हैपनिंग. व्हाट यू हैव टू कमेंट इज अप टू दिस प्लॉट 5000 बहुत ज्यादा हो गया. एनीवेज इट इज गिविंग अस आउटपुट वेरी परफेक्टली. सो फॉर 5 आल्सो इफ यू आर जस्ट डूइंग, just plot it up to 5 and say that we have plotted up to 5, and whatever nature of the graph is giving up to 5 seconds, the same nature will be kept intact even if we are going up to 5000 or infinity. So you are finding at 5 how much is the amplitude. Okay, so it should be 12.5, because 5 into 5 25 divided by 2, because it is t square by 2. Okay, so are you getting 4.99 is 12.45, and at 5 it will be 12.5. Okay, so t square by 2 समझ में आ रहा है guys? So t square by 2 means 5 into 5 25 divided by 2, that is 12.5. That is the input. Okay, so input is 12.5, and how much is the output? Output is not growing that fast. Okay, so at 3 you can check 3, it will be 4.5 around. ये देख लो. Okay, so this is t square by 2. देखो almost 4.5, 2.95 में इतना है, so 3 में it will be 4.5. And output is not growing that fast. So at 5 almost output is going to be not even 1.92. So how much is the difference at 5? It is 12.5 minus 2. So error is 10.5. At 5 seconds the error is 10.5. And as time growing, you are finding that this distance is growing. Okay, so I think enough of discussion on type 0 system. Okay, so now let us move fast and let us go for a type 1 system. So you have to do all those things now. Now type 1 system, let us go, and we will find out first what is GSHS for type 1 system. So what I'll do is, this is S into S plus 5. So response time domain में देखना अच्छा है, but one very important thing here is we are actually doing everything in GSHS. So from open loop, actually we are calculating everything in the closed loop error. So from open loop function, we are finding everything in the closed loop function. So now our GS is 1 by S square plus 5S, or S into S plus 5, HS equal to 1. So what is GSHS? So what is TS? This you have to find first. So what is TS? Is the same thing. So how much can anybody find and tell me? Now GS is 1 by S square plus 5S. So what is TS? So this is 1 by S square plus 5S divided by 1 plus 1 by S square plus 5S. 1 by S square plus 5S plus 1. Can anybody tell me what is the closed answer? Can you tell me? Is it understandable how you're getting it? Okay. So GS is equal to 1 by S into S plus 5, that is S square plus 5S, and TS is equal to CS by RS. So this 1 by s square plus 5s divided by 1 plus 1 by s square plus 5s. So from this you can find out. Is it obtained? TS? Anybody please respond? Le.
Yes, sir.
1
So
by
1 by
s
s square
square
plus
plus
5s
6.
plus 1, you agree with it, right? So everything we will find for unity. So first we will find for unit step and how it goes. So a is equal to 1. First let us find Kp. Can anybody tell me what is Kp here? So how much is Kp? Limit s tends to 0, s into 1 by s into s plus 5. Okay, first we are finding Kp. So Kp is limit s tends to 0, 1 by s into s plus 5. Can anybody tell me what is Kp value?
Infinity.
इतना तो बता दो, 2 सेकंड की बात है.
Infinity.
लिमिट s टेंड्स टू 0 GSHS, इधर से देख के ही बता सकते हो. How much is Kp value?
Infinity, sir.
Infinity. Very good. Thank you.
Infinity.
So what is Kp? Kp is equal to limit s tends to 0 GSHS. Okay. So GSHS, whenever you are doing, you are finding there is coming this GS. This S is coming at the denominator. So GSHS is nothing but GS. तो अभी GSHS भूल जाओ, सिर्फ GS ही करो, because HS equal to 1. ये छोड़ देते हैं, ये नहीं लिखते हम लोग, because HS might be creating some confusion. Okay. So closed loop transfer function is GS by 1 plus GS, because HS equal to 1, no problem. So this is 1 by s square plus 5s plus 1. This is transfer function we have found out. But whenever you are trying to find out Kp, you are finding that this is 1 by. So Kp is equal to infinity. Kp is equal to infinity. Kp is equal to infinity means how much is the ESST? How much is the ESST? So this is 1 by 1 plus infinity. Are we finding 0? Steady state error is 0. Is it understandable?
Yes, sir.
Okay, because this is 1 by 1 plus Kp. So as Kp is equal to infinity, that means steady state error will be 0. Steady state error will be 0 means if we are giving input as unit step, output also will reach to the unit step very perfectly. This I have to prove. So एकदम output unit step पे जाके रुक जाएगा, because we are giving unit step. So ys is equal to, now I will change the ys. Ys is equal to, now this is 1 by s square plus 5s plus 1. So let us check that. Okay, like this. And c is equal to ys by s. So this will be step response. This will be step response. That's it. Okay. So this is the changes now. So what we are finding is Kp is equal to infinity, and ESST is equal to 0. ESST is equal to 0 means input should be equal to output. So step response is equal to I Laplace. So just see how it goes. अरे बाप, ये गड़बड़ हो गई. ये गड़बड़ हो गई. Well, then let's try whether we can get it or not. So exponential 5t. So इसमें थोड़ा trick है. Let me just see whether we can find it or not. So let us plot t and response. No problem. Wherever there are multiplication things, so 5 into t cos this t, 5 by 21 half and hyperbolic. So let us just plot it, whether we are getting it or not. So exponential 1 minus 5. So here there should come a dot like this, and let us see. In this case, error should be 0. That means output should go and reach exactly to 1. So output is going to 1, but it is not going to 1 here first. So what we will do is we will put for some more time, 50. Let us see whether it happens or not. Okay, so output is going to input very slowly, but eventually it will go because we are having time till t is equal to infinity. Let us see how it goes. 50 में भी शायद नहीं होगा ऐसा लग रहा है. देखो, दिख रहा है? Guys, are you able to see that the output has reached to 1 perfectly? समझ में आ रहा है? So what is the steady state error now? Steady state error is equal to 0, but that is not happening here. That is not happening soon. Okay, so what is the output value? Output value you can check here. Okay, so output value you are finding that output has exactly reached to 1. So you can find here what is the output. So output is equal to 1 and input we have given as step. Okay, so it is still not exactly 1, but yes, almost equal to 1. So output is reaching to the input because this is a step response we have plotted. So if you see the example here, so this is the way the output is increasing. So here what we have plotted is this is a response for this is the response. So what we have done here, you can check, this is the first case. What we have done, this is a system, this is a type 1 system. This is the first thing. Why type 1? Because GS is to 1. Type 1 system, I have found GS by 1 plus GS because H is equal to 1. So this is the closed loop transfer function. I have given unit step input, KP I have found as infinity. KP is infinity means steady state error is equal to 0. Steady state error is equal to 0 means input and output, they are same as time increasing. So this is the CS actually what I have found. This is the CS. So this is the response. Okay, so this is the transfer function and this is the output YS by S, and I am finding what is the step response. So first I have taken what is the time domain thing here, and then I have found out here. So what all things you have to do here is wherever you are finding, so very big caution you find here, this is cause time and this is also time. So whenever two time things are multiplied, you have to put a dot here in between. Here also you are finding there is one time axis and there is another, so between that, so here I have to put a dot. So whenever one time and another time they are getting multiplied, it has to be point by point multiplication. So here there will come one dot and you have plot the response. So this is the first type 1 system step response, and if you are running it, you will be finding that difference between input and output, there is no difference. That means there is no steady state error, and this is a very good graph and you can find here. But the best graph is going to come next. Okay, that is the first order system, sorry, type 1 system and ramp response. So this is the step response of type 1 system, and you are finding that out to the input. There is no steady state error. Okay, that we are finding here. Next is I will go to the same thing, that is the inverse Laplace thing. Can you calculate how much is the KV here? In calculate how much is V. So what is KV? KV is equal to limit S tends to 0, S into 1 by S into S plus 5. So SS gets cancelled. Limit S tends to 0, 1 by 5, that is equal to 0.2. Has anybody found KV is equal to 0.2? Has anybody found KV is equal to 0.2? What is the formula for KV? Limit S tends to 0, S into GSHS. Okay, so whatever you are finding here, this first has to be multiplied with S. That means this S at the denominator, it goes. And then you have to substitute S is equal to 0. So what it will become? It will become 1 by 5. Are you getting 0.2? Anybody getting 0.2?
Yes, sir.
Yes, sir.
Okay, so if KV is 0.2, how much is ESST? It is 1 by KV. That is equal to 1 by 0.2, that is equal to 5. ये सबसे interesting graph है. ये graph एकदम जबरदस्त है. So if we understand this graph, हो गया. So lastly, what was the ramp response you found? Two ramps were diverging. यहाँ पे भी ramp आने वाला है, but they will be parallel. ये सबसे, this is the sweetest waveform. We will see that. Okay. So now A is equal to 1 because we are giving unit ramp. So this unit step input, we will make it now unit ramp. So type 1 system and ramp input. ये सबसे जबरदस्त output है. So A is equal to 1, KV is equal to 0.2. How did we get KV is equal to 0.2? Here GS HS is equal to 1. छोड़ दो. So GS only. Substitute S into this. That means this S and S gets cancelled. So S plus 5. This is 0 plus 5. 1 upon that. That is KV becomes 0.2. So ESST is equal to 1 by 0.2. That is equal to 5. So this 5 will prove. So throughout the time you will be finding that throughout the time, मतलब t is equal to 0 to infinity. 0 में तो नहीं होगा, थोड़ा आगे जाके दोनों पैरेलल हो जाएगा एंड दोनों में कोई भी पॉइंट में 5 का डिफरेंस रहेगा. सो वो थोड़ा इमेजिन करना डिफिकल्ट है. आई विल शो यू. Okay, so how to find it now? So this C you have to change now. So this is, make it comment, and whatever is the ramp thing that you bring here. So wherever was the ramp response, you just bring it here. I think it was here only. So YS by S raised to 2. Idhar hi kar do, S raised to 2. Okay, so this you make it ramp response. ऐसा ही रखो इसको, कोई प्रॉब्लम नहीं है. So this is uncomment. समझ में आ रहा है? So now this YS is the G by 1 plus GH. ये हो गया. H is equal to 1 and YS by S square. Because I told you whatever is the transfer function, you have to multiply the RS with that. So RS is nothing but 1 by S square and then ramp response. So first इसका inverse ले लो. So first just take the inverse of this. Save. And ये एकदम बड़ा सा कुछ तो आने वाला है ये. You should not get scared. हाँ, ये देखो एकदम बड़ा सा आया ये. So just copy this and take it to the time domain. ये थोड़ा समझ के करना है यार. ये इतना, this is not tough, but it is actually reducing our work. So जहाँ पे अटकेगा वो देखना है. V. And we are not going to plot for 50 and we are not going to plot for 0.1. Okay, so what all changes we have to do here? First you have to understand that is wherever there are multiplication of 2t. So this is the first term t. Okay, and 5 exponential t and cos. So यहाँ पे एक dot आने वाला है. Why? Because this is a t term and this is also another hyperbolic t term. So दोनों का multiplication, it will be dot multiplication. Then here it is there. Here there is a multiplication like this. So just check what all terms are there. So there, this is a ever increasing term t. This is the response. This is the response means this is CT. The sweetest response we are going to see now. So this is the t. Okay, and this is 5 exponential t. So this is that exponential waveform, exponential sine cos. So ये थोड़ा undulation देने वाला है. And this is a constant term. Now just plot it, and you will be finding. And remember, you have to remember that. What is it to remember? What is the difference between input and output at any time at steady state? Any time and steady state. So थोड़ा देर बाद difference between input and output will be 5. So वो दिखाना है. So at any bigger time, difference between input and output will be 5. Let us see whether we get it or not. कौन है? अविनाश गनाचारी. Okay, I'm sorry, I did not plot the input. I'm sorry. This is the output that we have plotted, but we have to plot the input because, so this is t comma t. T comma t means because this is t comma t, this is time and this is the amplitude because this is unit time, unit t. If I say this is 2t, so you have to do here 2 dot t, 2 multiplied by t. Okay, and थोड़ा बड़ा लेते हैं time, 20 ले लेते. Okay, so t comma t is the input. So this will be the blue graph, and t comma response, this will be the output. अभी input output दोनों आएगा because there is no point plotting only the output. You will not be able to see anything. समझ में आ रहा है? At any time you just check. So previously the input and output, they were diverging. A blue line ऊपर से जा रहा था and red line इधर से जा रहा था. They were diverging. Here ऐसा नहीं है. यहाँ पे देखो, कोई भी एक टाइम में आउटपुट देख लो बस. Okay, so so this is type 1 system. Type 1 system at 16.1. How much is the output? Output is 11.274. And how much is the input? Can anybody tell me what is the input at 16.1 second? What is the blue graph amplitude at 16.1 second?
16.1.
16.1. Very good. Thank you. Who is this? Kiran?
Mohit sir.
Okay. So input is same. So input at 16.1 will be 16.1. And what is the red graph at 16.1? It is 11.274. So what is the difference between that? 16.1 divided by 11.274. How much is that? So around 4.926. ये जो 4.926 का डिस्टेंस है, this will be maintained. So now I have made it up to 20. अभी क्या करते हैं? I will plot it up to 50. अभी देखो ये blue line and red line. यहाँ पे this is called lag. This is called lag. Okay, because this red line is lagging the blue line. Red line is not going up as fast as the blue line going. So this blue line शुरू से ही वो बढ़ रहा है, आगे बढ़ रहा है. But this red line initial, so this is something उसको कुछ backlash या कुछ तो बोलते हैं. So initially there is a backlash. So red line cannot increase as fast as the blue line. But एक बार red line increase हो रहा है, so up to 20 we had plotted. Now we'll plot it up to 50. So ये देखना 4.5 का ये जो gap है, 4.9 का ये जो gap है, this gap will be maintained. This is the thing I want to show. So at 16.1 I have shown you the output. So this is type 1 system. This is ramp output. अभी देखो ये दिख रहा है अभी. Kiran, is it understood the difference between type 0 system ramp response and type 1 system ramp response?
Yes.
Guys or girls, whoever are there, please respond. Type 0 system ramp response and type 1 system ramp response. What is the difference? Type 0 system ramp response, blue line was here and red line was like this. Red line was like this. So distance between blue line and red line, it was ever increasing in case of type 0 system. That's why at t is equal to infinity, the distance was getting bigger, and at t is equal to infinity, the distance was becoming infinity. So steady state error or difference in input and output at any time for type 0 system, it was increasing. But in this case, you are finding that this distance is ever constant. You'll be finding. Take any point. Take any point. So this is type 1 ramp response. So at 42.2, how much is the ramp input? Ramp input will be 42.2 only. And how much is the ramp response of first type 1 system? This is 37.2. So how much is the distance? Distance is 5. Is it understandable? Anywhere you check, anywhere you check. So at this point you can check. What is this point? Next point. Next point is 47.9. So at 47.9, input will be 47.9 because input is unit ramp. Okay. And how much is the output? It is 42.9. And how much is the distance between that? Distance between that is 47.9 minus 42.9. That is distance is 5. So ये जो हम लोगों ने plot किया था, whatever thing we had plotted previously, and we had written that kV value was 0.2 and ESST is equal to 1 by kV. That is 1 by 0.2 is equal to 5. Are you able to understand what is that 5? So that 5 is nothing but the distance between the input blue line and output red line at any instant. Those who want, you can plot it for very big values. So you can plot it for, let's say 500. Okay, let's say 500. We'll plot it for 500. Type 1 system and let it plot for very big time value. Okay. And at 500 also you will be finding output as, can anybody tell me how much will be the output at 500? Okay, so this part. Okay, so this part will be 495. You can find out. So how can we get it? We have to use a axis command. Okay, so this is 300, 400. So it is not going up to 500, but we could plot it. So if you are doing this axis command, you will be finding that this is exactly following the input. So all those things can be very easily shown. Okay, chalo 300 mein karke dekhte hain. So let us plot it up to 300. 500 if it is not pulling up, no problem. So let us plot it up to 300. So 300 mein output will be 295. That I can show you. The difference between input and output is always 5 because kV is equal to 0.2 and so only this part. So axis, you can take the help of axis command. Okay, you can take the help of axis command. and you can plot the distance between input and output. So here, what is the axis I will take? So axis between, you can say 2 x-axis, so you can say 275 up to 300. This is the x-axis. And what is the y-axis? It is also, you can say 250 or 275 up to 300. So actually by this axis command, I am actually enlarging this part. So from 275 to 300, so this part I am enlarging because I want to show you that the difference between input and output is equal to 5. Steady state error is equal to 5 units. I made a mistake, so I'm sorry. This is 300, it should be. Axis command में थोड़ा mistake हो गया. Like this, I'm sorry. This is 275, 300. This is x min, x max, y min, y max. So I'm just enlarging a range and I'm showing it to you. देखो. So blue line is the input. At 275, amplitude is 275. At 300, amplitude is 300. Okay, so this is the unit ramp. And at 280, you can check how much is the 280 amplitude of the output. At 280, the amplitude is 275. That means what is the difference between 280 and 275? So at any point, you have to just cross, you have to draw a perpendicular line. And on that, whatever is the input and output, and that difference will be maintained at 5. So this is the most important graph and to understand. And this is a parallel, like a rail line. So at 300 input will be 300. So there is no doubt about that. At 300 input will be 300, and at 300 how much is the output? Let us see. There you go. Okay, so that is actually showing for above graph. Below graph it is not showing. Below graph it should show now. Okay, so this is 294. That means almost 295. So this is 295. So this is the most important graph. Is it understandable, guys? What is type 1 system ramp response? Is it understandable?
Yes, sir.
Okay.
Yes,
so
sir.
now this graph goes like this, parallel. Previously it was like this. Previously input was increasing in this way, output was going like this. So this was diverging. Now both are increasing, both are unstable. But that instability between both these things are keeping constant. So it is like a channel. They are creating like a channel. Okay, and that's why it is called a steady state error. Even at the infinity, if this input is infinity, output will be infinity minus 5. Okay, so ये सबसे जबरदस्त waveform है. That is type 1 system with ramp input. Okay, so ये सबसे अच्छा समझने वाली चीज है. Now what we will do is we'll go for type 1 system with parabolic input. Okay, so type 1 system with parabolic input, that is S cube, and we will see that this is parabolic response. I Laplace of 3. But before that, we have to find what is Ka, Kp, Kv, Ka. How much is Ka now? What is Ka for this type 1 system? So this is limit S tends to 0, S square into Gs into Hs. Okay, so numerator there is a S more, and it will be 0, I think. So Ka will be 0, Ka will be 0, and this will be 1 by Ka, that is 1 by 0, that will be infinity. We have already seen this. But again we can see here. So this is a parabolic response we are finding. Let us find out. So this is Ys is equal to 1 by S cube. So this is type 1 system parabolic response. What we are plotting. So very big thing has come, so no problem with that. We know what to do. We'll just take it here. V, and we have to see what all things are there where we can change. So first thing is this has to be made T square by 2. Okay, so this is the first change we have to make in the output, because there will be a blue curve which will be a parabolic response. Okay, that is the first thing. Now here you are finding there is a T square term in the response. That means the response is also becoming a square. Okay, Now this 2 exponential 5t, so this will be dot. तो ये सब point बहुत परेशान किया हम लोगों को last few years, but we have learnt it. Whenever there are two multiplication kind of thing, this is matrix dimension matching. So इधर नहीं चाहिए, इधर dot क्यों नहीं चाहिए? Because there is no t term here. Whenever there are multiplication of two t term like this, in this case, okay, this is exponential e raised to minus 5t, and this is also t. There you require a dot. Likewise, so this is t square by 2. That means you are plotting first parabolic, and with respect to t, you are plotting response. देखते हैं what do we get. कुछ mistakes है तो correct. There is a mistake somewhere. So this is 5t response. Let's see where is the mistake. So this is t square by 2, 5 into t exponential cos hyperbolic t. I think here also they're expecting a multiplication dot. So let us see now. T square by 2, 5t. Element wise matrix power. Okay, so matrix power also requires that. So this is t dot. So here also it will be t dot raised to like this. I think it will come now. Okay, so what we are plotting? We are plotting for type 1 system, and the blue line is the input line, and the red line is the output line. So you are finding that the distance is not constant. The distance will be increasing, though they are looking very similar, but you can see that the distance is not constant. So if you are just plotting it for very big time, so you just see here, आँख के नजर से समझना चाहिए that the distance is not constant as it was in the previous case. So towards the left side, it is almost aligned blue and red line, and as the time is going by, their distance is becoming bigger. Okay, so if you plot it for, you say, let's say 3000, if we plot it, let's see whether we are getting a bigger distance or not. Okay, so this is the fun of MATLAB, that you can do very big things and within a very small frame of time, and it can help you. So output is not getting produced for such big thing, but I think up to 1000 it will show. So this is a matrix dimension thing we are getting stuck at. So at least 1000 if we can get. No, it is not also coming at 1000. So up to 300 only, 300 or maybe 500, I guess I will get it. So only what you have to understand is, unlike the previous case, in this case you will be finding that the input and output distance, it is increasing. So as time is going towards infinity, that distance between input and output will become infinite. Okay, so almost up to some 325 or something. So this is, I think 314 it is coming, and you are actually finding that this distance is increasing. So up to 50 it will show us a good show. Let us see up to 50. And unlike the previous case, it is not going to stay constant. It is going to diverge. Up to 50 if we are doing, it will give us a good show. Red line is trying, so either. Okay, so red line is trying to catch up the blue line, but yes, there is significant difference between that. So at any time you are finding this distance is actually the error at any time. We cannot call it steady state, because at steady state the error will be infinite. At any time we are finding that this distance is increasing, and you can find out that y-axis is very steep. Okay, y-axis here 1400 may get already. Okay, likewise. So at 50, how much will be the input? So it is 50 square divided by 2. So at a kind of 1250. Okay, so at 50, the input will be 50 square by 2, because the input is actually t square by 2. So at 50, the input will be around t square by 2. So it will be around 1250. So here it is around 1220. And the output is not that much. So output is little less. So whatever is the output, and that output is, the difference is increasing. Okay, so this you can show. So whenever you are drawing this graph, you have to show 2 points. So you can take amplitude at 30 and you can show amplitude at 50, and you have to show that the distance between the blue and red line, they are increasing. So the logic will be, as t tends to become infinite, in that case this distance also will keep on becoming infinite. So that's why this is called as a infinite steady state error. Actually never the waveform goes into steady state, but we are calling it steady state error because we are trying to find the difference between input and output at infinity.